Welcome to the Harman Professional University AES67 overview video. So what is AES67? It's an open standard for audio over IP interoperability based on existing standards. The keyword here is interoperability, considering that AES67 is not a new protocol, but it provides us a methodology for allowing diverse networked audio systems to transport audio to one another. In the past, when faced with the need for propagating audio between two or more systems utilizing dissimilar audio transports, we've relied upon using point to point connections such as analog, AES3, or MADI, just to name a few examples. These point to point connections, while proven reliable in many installations, can come with their own set of drawbacks considering the increased cost when accounting for the additional need of hardware, which in turn can also lead to other potential points of failure. Factor increased latency added in the transcoding stages and possible signal degradation as analog audio passes through multiple conversions of analog to digital and digital to analog, and we're left wondering if there's an easier way to connect multiple audio transports. Consider the wide array of networked audio transports available today. Some are proprietary in nature, while others have been accepted as industry standards used by many manufacturers. The common element they each share with one another is that they are incompatible when needing to transport audio data from one to the other. Introducing AES67 allows our networked audio transports to seamlessly share audio with one another. One analogy that may help us better wrap our heads around what AES67 is and how it compares to networked audio transports is to liken it to the differences between a Microsoft Word document and a plain text file. The Word document contains many formatting and publishing characteristics that provide stylizing such as font choices, layout rules, design themes, and maybe even illustrations in addition to the words and punctuation. Microsoft Word may be our preferred choice for word processing, and while many word processing programs may sport similar tools, they are not all equal. What do we do if we need to distribute a Word document to another person for proofing and we're unsure if they use Microsoft Word? Well, in addition to sending the Word document, we can send them a plain text file considering it has all the important words and punctuation that the other person needs to see without including all the unnecessary Word document formatting. Because the plain text file is a common interchange format, we know they'll be able to open it. AES67 is the equivalent of the plain text file. It has the core information of the signal needing to be exchanged among the differing networked audio transports, while not trying to provide proprietary information each transport may use in their individual atmospheres. When considering the attributes of AES67, first and foremost, we find that it supports professional quality audio, meaning we can expect full bandwidth and low noise, uncompressed linear PCM audio with a minimum resolution of 16 bits at 48,000 Hz. Secondly, AES67 targets to keep latency below 10 milliseconds as necessitated when considering latency thresholds for same room presentation systems and sound reinforcement. Typical latency can measure at 2 to 3 milliseconds, however, this is not a guarantee. The third attribute of AES67 to consider is its high capacity channel count. Up to 512 channels at a sampling rate of 48,000 Hz can be supported across a gigabit network. AES67 leverages well-defined standards. For synchronization, Precision Time Protocol version 2 is used. Because it utilizes a best master clock algorithm, devices supporting AES67 will negotiate with one another and determine which one should act as the master clock. A second standard used by AES67 is multicast packet transport through the use of Internet Group Management Protocol version 2. There are two multicast streams. Audio is published across the 239.0.0.0/8 range, commonly on port 5004 as it is reserved for RTP traffic. The clock is distributed over 224.0.1.129 through 132 multicast range on ports 319 and 320. AES67 implements a quality of service standard known as Differentiated Services Code Point Classification, or DSP for short. AES67 supports three different point classifications, with the clock traffic at DSCP 46 taking the highest priority queue of 4. Audio packets at DSCP-34 are the second highest priority queue of 3, and all other remaining DSCP values are set at the lowest priority queue of 0. These are internally managed and do not require user configuration. The last standard is session information, which is distributed through the Session Description Protocol, or SDP. This includes multicast address information, port number of the stream, encoding format, and packet setup. Essentially, this contains all the necessary info that the receiving endpoint requires to properly decode the audio. We'll also find that it's used by programs like Dante Controller in order to see the AES67 streams, making it possible to route them to other AES67 capable devices. Note that in conjunction with SDP that there is no defined methodology for advertisement and discovery or connection management information. The most commonly implemented standards are SAP and MDNS RTSP, but not all devices support both, and some devices support only manual configuration. The obvious question is, if everything talks AES67, is that what I use across the entire system? Well, just because you can doesn't mean you should. AES67 is the standard for high-performance streaming audio over IP interoperability. It's the words and punctuation. It doesn't provide all the bells and whistles found in other proprietary network audio solutions. Take, for example, Dante. It allows us to transmit extra information across the network, such as status of devices. Also keep in mind, while AES67 aims for latency targets less than 10 milliseconds, if we must guarantee a latency of 5 milliseconds, then it would be wise to continue using one of the other audio transports that allows us to configure that setting. It is only when communicating between systems with different native transports that AES67 should be used as a common transport or bridge. This approach allows rich transport-specific functionality within the subsystems, but facilitates a more basic audio connection between subsystems when necessary. Let's look at a simplified transport flow starting with an AV source connected over HDMI to an encoder. The video is transported as a JPEG 2000, while the audio is available over the network as an H.264 PCM stream. At the other end, we have a decoder connected to the display using HDMI. In parallel, we can find a Dante network with the Dante source being routed to a DSP, providing audio processing for both Dante and AES67, in addition to other source types depending on its card configuration, and finally the audio can be routed to a Dante amplifier. Utilizing AES67, we can inject the encoder audio into the DSP for processing, and then route it along with any other audio channels back to the decoder as the application necessitates. From a Harman perspective, a more fully populated system may be split into 2 or more subsystems. In the first subsystem, we find 5 sources, each being connected to an AMX SVSI networked encoder, such as the 2412A, and a PC running Dante Virtual Sound Card, all being connected to a networked switch. We then find subsystems 2, 3, and 4 with their respective network switches. Subsystem 2 consists of 2 AKG DMS800 wireless microphone systems with Dante outputs, a BSS SoundWeb London Blue 806DA acting as our centralized digital signal processor with support for both Dante and AES67, and 2 Crown amplifiers with support for Dante and AES67. Subsystem 3 contains a BSS SoundWeb London Blue DA, which can act as a bridge between AES67 or Dante and BlueLink audio. Audio received by the Blue DA is BlueLink to 2 Crown DCI networked amplifiers. And finally, Subsystem 4 hosts a series of AMX SVSI 2422A decoders, which are respectively connected to their own displays. As we can see here, AES67 and Dante are cohabitating and can be processed by the 806DA. Audio from the encoders is received as AES67, and audio is transmitted to the decoders as AES67, while audio from the PC and other sources like the DMS800 microphones is processed as Dante. This concludes our brief overview of AES67. Thanks for watching.